Welcome to the second episode of the second season of the Kern Competence podcast. Today I am once again joined by Simon. Simon, welcome.
Thank you, Marvin, and welcome to you.
It's been quite a while since we recorded the last episode. I have been very, very busy. I think you have been even more busy. So a small apology from me to our dear listeners for the long break. But we have a very cool program planned for the next few episodes over the summer. We even are going to record the next podcast episode next week, so I don't think it's going to be a 5-month break until the next episode. I think what would be a really good start is to catch up. The elephant in the room is it's the first few months under the company AMETEK. How has it been?
Wow, yeah, that's quite a big question.
Loaded question. Yeah.
I think that differs a little bit from whom you ask in the company. So, big American company, of course, the first thing that comes to mind is internet security. Second is accounting, and I also learned some new things, not just US GAAP. I knew that before. I don't know if our listeners know, but there's a Sarbanes-Oxley Act and things like that. A procedure that just gives more security to the shareholders of a big corporation, and a lot of things to do also on our end. So I think Kern always was top notch when it comes to IT and also accounting, but controlling. But I can say something came on top. So if you ask IT, HR, and finance, they would say, "Oh my God!"
Yeah, they kind of looked a little bit afraid over the last couple of months. Yeah. Slowly, it's grooving in, I think.
Yeah, it's getting better, and I think everybody understood that's important. And of course, there's a little bit of pressure, but I would say also what I mentioned in the last town hall meeting with all the folks here is most 80% of the people working here at Kern, nothing actually changed. So we have a small AMETEK below our Kern logo. And of course, the biggest impact is at Sebastian's and my side, I would say. And if you ask me personally, I would say there was a lot of work at the beginning. You can imagine, and I think we shared that in the last episode, that due diligence phase and everything getting closer, getting more concrete, and finally making the signature. This was a big pile of work, and afterwards we were really craving for some days off, and it directly started with the integration. So the first 3 months were also kind of very busy, but in the meanwhile, I'd say super positive. Something I can share, for example, we've been invited to AMETEK University. AMETEK's not just in Pennsylvania, where their headquarter is, but also they have a bigger subsidiary for corporate in Naples, Florida. There are worse places to be, yes. I can say. And we've been invited to the AMETEK University, and it was 100 people and the whole leadership team. So chairman of the board for full 3 days.
Which is quite exceptional because, I mean, AMETEK is a very large company, over 22,000 people. That the chairman of the board has time, or takes the time, I don't think he has the time, but takes the time to attend a leadership meeting for the full 3 days. That's exceptional.
Yeah, and you can bother him the whole time, and I did, so I really drove him crazy. I can imagine.
I saw the picture, like the crew picture on LinkedIn, and it was just like the management team, chairman of the board, like in the middle of the picture, and directly next to them you were standing.
Yeah, Simon with the broken arm.
Yeah, with the broken arm, with the broken shoulder, and I was like,
it was just literally. Dave said that at one point. So Simon. 150 people in the room. I always know where you are. I guess it's always where's the loudest and whatever. So I do not exaggerate when I say this was one of the best events I've ever been on. So it was full days working workshops. We learned a lot about how they look at things, how they see things, with all humbleness. So the key takeaway is and there's just leadership teams invited and say, we want workhorses, no show horses.
Yeah.
And if you look at the team and board of directors, there are at first glance not a lot of show horses there. And yeah, it was pretty busy. Every minute of the day was actually with Sebastian. I went to the beach for 20 minutes on the first day when we arrived before the event started. And after that, there was not a minute of free time. Till the evening, you had dinner together, you had some drinks and beers and whatsoever, and could talk things and meet people, all exceptional. I think same thing in the expression we had in the first place is all experts, knowledgeable, respectable people. So that was our impression, a lot of things we learned. And even Sebastian said on the way home, I'm leaving more intelligent and knowledgeable than I came here. And I've never in 20 years heard that before out of his mouth.
Typically with Sebastian, he just knows things, or he believes he knows things. So that's actually quite exceptional. Yeah, I mean, that meeting people is something which, when AMETEK made their introduction to the Kern family, they told us we are now part of the AMETEK family. In the beginning, I mean, pretty much everyone listening to them was like, okay, this is big management talk. But it has been that way. There's so many new connections, so many amazing subsidiaries of AMETEK, and it kind of feels like those first 3 months were extra busy because everybody was visiting. I'm unsure whether this happens every time they buy a new company, but it's just like an influx. Like pretty much every day in our canteen, we had a reserve table for just like AMETEK subsidiaries, and sometimes it was 2 of them visiting, looking for opportunities to share it, and amazing people, amazing conversations with them, talking to them, and very openly. That was really cool.
Yeah. Okay, I still have in mind the Zygo meeting we had once in the evening. That was really exceptional. You talking to some guys that was just like felt a little bit weird. So because everybody was so excited, talking about Angström and so on, so people were shaking.
It was really cool. Zygo is one of the most technologically advanced companies in the optics world. I mean, if you want to measure surface roughness or a lens with white light interferometry, there is pretty much nothing better you can buy on the market, and we knew that before. Something most people don't really know about Zygo is that they also have like a large optics manufacturing business, and there they are world-class, exceptional quality of the optics. They also produce their own optics for the interferometers, which nearly no one does. Most other companies, when they do an interferometer, they buy lenses from the big Japanese companies. And we had, just in visiting the head of the optics division, it was such a technical conversation. And typically you would expect if like a management person, like head of optics manufacturing, if he visits, that he's a manager and he talks about money and margins and production. But instead it was a very technical conversation about Angström level subsurface damages, and it was really cool. I'm not quite sure whether you were bored or just like vibrating in the vibe Justin and I had, but it was really good.
Yeah, it was really great to attend. Good experience. And yeah, also I think I shared that in I should have listened to the last podcast. It's already out of my mind. Too much alcohol in the meanwhile, or I don't know.
There was also quite a bit of alcohol in the last episode, I think.
Right. And but what I say, so we have this tariffs through the Donald and whatever you want to think about him, but we're helping each other out in talking about possible solutions. So giving platform and space for American companies within the AMETEK group to come here and to do things, and also the other way around. We get great support with the tariff discussion, getting exceptions or alternatives to go through that process. And right now, I don't know how many people we are trying to hire globally, and we have AMETEK teams everywhere, and they help us finding good candidates and so on. It's just a big step up. So to summarize, there are some departments, people here in the company that feel pain. The majority is not feeling anything, I think, through AMETEK right now, because it's really standard business. We're doing really good this year. We had a massive order entry in the last year, and even if the situation right now is a little bit, there's tension, I would say, but we're doing good. And we're winning our projects, and we're bringing our projects forwards, our R&D projects as well as our sales projects, and so we're doing good. They are very appreciative, and from my perspective, summarized is after 3 months or the last 6 weeks were really good. So enjoyed working with a bigger team, getting instant help, getting things done where we usually have to ask external companies. And now we have colleagues that are really intrinsically motivated to help us. And one thing I want to share also on AMETEK University, you go in there and it's 100 participants, and I would say I roughly know 10 of them. Everybody knows us.
Yeah, okay.
Everybody knows Kern. And this is just, you join a meeting and they say, chairman of the board says in a Teams meeting, yeah, welcome everybody. Hi, Simon. How are you doing? Which is pretty cool. And the others say, wow, yeah, we're a little bit pissed off by Kern, because every time something's not going right at our side, we hear from top management back, talk to Kern. I think they know how to do it. And I hope this honeymoon phase is going to last a little bit longer. Yeah. And doing good.
Yeah, I mean, I wouldn't agree with you that the majority of people are just like have no opinion here. Because, for example, for the technology, I think like for engineering and also for applications, and for me, it has been fantastic to exchange ideas. You already mentioned one of the subsidiaries, Zygo, but there is, for example, also the Taylor Hobson subsidiary. We had Bob come in and hold a presentation for our engineers about how engineering is done at Taylor Hobson and about like the principles they have in their machine. And typically, I would guess that some of the slides are something they show in public, like when they get asked. I mean, we also get asked to hold presentations, technical presentations. But he was sharing us such a deep dive into how these Taylor Hobson measurement machines, they're very well known for measuring round parts, how they actually work and how they do the engineering and how they do the manufacturing in-house. And it was so interesting to exchange ideas there. And then a couple of months ago, I visited the AMETEK Germany headquarter in Weiterstadt. It's directly next to my hometown, so I was using a visit to my parents to just say hello there. And Lufos is situated there, and that was also a really cool conversation. The head of the business unit, Lufos, he took like 2 hours of time to show me everything, how they do it, and they have a very cool metrology machine for measuring rotationally symmetric parts. So, for example, lenses, and the approaches they do, they are like really fantastic with like a metrology frame and a kinematic frame. It's like you open a really high quality engineering textbook and they just applied everything correctly. And then they have like a super differentiated product, and it kind of feels like you're talking to the same person like we do here, just doing a different product, same mindset. So that's really cool.
Yeah, that's good to hear.
And I mean, it's also really nice how much you can learn from them, because I think we know a couple of things really well. We are masters of temperature, and we know about compliance. And I do not mean the business term compliance, I mean the mechanical engineering term. So
I'm afraid I know what you're talking about.
You maybe know about compliance. I just got very good friends with the AMETEK bookkeepers, and that helps out a lot. Yeah. And Lufos, for example, they are amazing with interferometers, just like measuring a distance in an absolute sense, and exchanging those ideas with someone who has like the same level of expertise and who is completely open, more open than any supplier would ever be with you. That has been exceptional from a technical perspective.
Well, it's good to hear. Any other experience you've made, for example, with Zygo, etc.?
Yeah, that was also really cool, mostly concerning actually my executive department at Kern. I'm working on a top secret research project, and I think this is going to revolutionize how surfaces are done on milling machines. I didn't tell you, the German Patent Office, by the way, said yes last week.
Oh, wonderful!
So it's
no,
gonna get patented.
That's just side information. Huh?
Yeah, just side information. So
Okay.
we're actually going to get a patent on this one. Going to take another 3-4 months for the patent to go through, but they were like, yeah, this is actually patent worthy. And we're now going into like a European patent. Exciting technology. I think we're going to talk about this technology more in depth in maybe 1.5 or 2 years when it hits the market. But it's basically us chasing the angstrom. And people who have milled surfaces before, they would now be very skeptical that a milling machine could ever produce an angstrom level surface roughness. But we've already done it, which is amazing. The problem is you need metrology equipment to actually measure this correctly. And I'm very well known at Kern to get like very expensive metrology toys here.
Oh, come on.
Yeah,
What a
yeah.
surprise.
Yeah. And something we have been missing was sub-nanometer surface metrology. So we have a Confovis Duo Vario. It's a German manufacturer for like a structured illumination confocal 3D surface scanner. And that one is quite fantastic. We bought it, I think, 9 years ago. And that one was good to single-digit nanometric surface roughness. Really reliable results. But going further down required an upgrade for our metrology devices. And this is something where I would have expected that now being a large corporation and being bought by AMETEK, that this would get more difficult. And it was actually, I think I stormed into your office like I usually do and was like, are you on the phone? And you were like, no, I'm not. And I was like, hey, Simon, I need a Zygo. And then it kind of felt like it was 3 phone calls, and we had a loaner unit here of their top-end model, the Nextview NX2, and that was just like mind blown that it's not a endless hurdle of bureaucracy and making fake business plans that we kind of would. I mean, this is really difficult to justify a metrology device for research in terms of a business plan. But it was just here. It was like, okay, yeah, we're going to send you one. It's going to be there in like 1.5 weeks. That was insane.
Cool.
The Zygo was put up by Peter Kushner. He's like the European sales manager for Zygo. He's been with Zygo, I think, 20 years. And he actually installed the device. And I mean, this is not a tabletop microscope. This is like fully air separated from the ground floor, super high quality, very expensive, the best interferometer you can actually buy for money. I was quite surprised when the sales guy comes in and he's like, yeah, he's gonna do the installation and he's gonna do the training. And he did the installation and then he did the training. And then I think I came into your office and was like, why can't our salespeople put up the machine? That was insane, that like such a technical level. Even at the salespeople, that he could just install the device.
It's cool.
Yeah. The Zygo itself has been exceptional here. I knew that they were kind of the best. Someone from like the basic research or foundational research at Heidenhain once told me, yeah, Zygo, seriously, if you do not want to build something yourself, there's nothing better you can buy on the market. And I knew that one. But if you look at their homepage, everything is a little bit old-fashioned on the homepage.
Oh my Jesus Christ! Yeah,
Yeah.
That is something that we have to adapt to. But we were lucky or unlucky. So we have Verena Höck here. She's, I think she's 23 years old and super enthusiastic about it. But we will have the first new shell AMETEK webpage, which is fortunately very, very close to what we have already.
Okay.
But everyone else is really, is not very happy about having to adapt to a new standard and doing all the work and whatsoever. So, that's a backside of a corporation, I think. And their web pages, Pressitech and so on, is really painful if you're from marketing.
I was kind of expecting from like the website and the marketing material that's out there, I was kind of expecting this to be an exceptionally well-engineered device and for it to have a horrible user experience. And we installed it and we got the training, and it's actually the complete opposite. Like, we have 2 other 3D surface CMMs. We have the Confovis and we have a Bruker Alicona, and both of them are not super easy to use. You really need to know what you're doing. But white light interferometry is kind of a cheat code for recording surface finishes. And on that machine, just like I'm going to now talk you through the workflow. I don't think I've ever told you how it works. You put your part below it, and then you just jog down the lens until something in your picture kind of flashes black for a moment. And the thing that's flashing black is basically those interferometer fringes you're seeing. And then it means you're slightly below your focus. And on every other device, you would kind of do the same thing. You would jog until your part comes into focus, and then you would start searching for the focus. Because on our shiny parts, autofocus most of the time doesn't work. Now, on the Zygo, what you do is you basically just jog massively down, just like until you see it flashing. And then in the software, they have a button where you press Find Part, and then it just scans to the top. So you're already below the focus plane, which means you can't hit anything. There's no collision that can happen, and just like super quickly jogs for the part. Now, in surface metrology, it's really important that your surface is kind of like perpendicular to the beam axis of your objective lens. Otherwise, you might shadow some features. And that device is equipped with like a tilt tip axis. So then the next thing you do after you find the part is you just press level part, and it just levels the part mechanically. It just starts with small humming motor noises and just like turns the tip tilt axis in. And then you kind of like you're already done. Then you just like press record, and then it measures it. And because white light interferometry has such a high resolution, but at the same time is so insanely quick, a like 100 micrometer height scan, which is enough for every surface we do, takes like 12 seconds. So this means from putting the part below the device until you have basically a perfect surface measurement, it's like a minute at most, which is actually quicker than those needle tactile 2D profilometers. There you need to be very careful to not shatter the diamond. And this was actually really surprising that that device is not only from a technological perspective insanely good, but also the user experience for recording a measurement is super simple, super robust, and just like really nice. That was quite surprising.
Good to hear. So I'm a little bit afraid that we have to have one permanently. Oh yeah. Okay.
Yeah.
But Marvin, also tell me about your electron microscope.
Oh, I think I'm very in love with it. I've been joking that if I like die in a sports accident, you have to bury myself with that electron microscope. It has been exceptional. It was installed at the end of March. It was kind of like, it was cool. And immediately we had like pictures with like a factor of 2 or 3 times more resolution. But over time, there's a large learning curve with this microscope. And luckily enough, I broke my ankle joint just before it was installed. I remember the training only through a haze of painkillers. But I had a lot of free time on my hands and spent most of it in front of the SEM. And it's just been exceptional, the insights you can get. So, for example, we've been looking at diamond cutting edges on monocrystalline diamond tools. And typically under every microscope, they just look flawless. They are just like, because they are lapped and it's a single crystal, and they are supposed to be the sharpest and smoothest thing ever. And 2 weeks ago, we took pictures of a tool and we were actually seeing surface morphology on the diamond. Just like seeing that there are small breakouts with a size of 2 to 3 nanometers. And this actually explains a surface phenomena we've been chasing on the machine. And just like that insane resolution where in our old scanning electron microscope you couldn't see anything because the diamond is non-conductive and it's very smooth, it was just showing you a perfect tool. And now you can actually see every fold on the tool. You can see the surface structure of the lapped diamond. That's pictures I don't think anyone has ever taken before, because typically if you deal in manufacturing and machining, you don't have access to such a device. So that's been exceptional. And I think 2 weeks ago we had our second size training on that one, and I wasn't on painkillers this time. It was super good as well. They sent one of their application engineers, Dr. Dirk Döhler, and he did a fantastic job. It was crazy. Routinely, and the magnifications we are always showing also when we upload pictures, it's always scaled to the Polaroid format. So basically a magnification of 1 would be a 6 centimeter large object is 6 centimeters on the Polaroid object. And if you have it magnification of 2, then it means it doesn't fit on the Polaroid anymore. It's basically half of the Polaroid filled out. So this is how the magnification is typically in the industry defined. And we've been making very nice pictures up to 50,000 times magnification. So this means your entire recorded area of interest, your field of view, is like 1.5 microns, which is already super tiny. And Dirk did a fantastic job on the training, explaining lots of principles, really showing how to handle all of the lens errors of the machine, how to adjust for them, because you can correct them. And then just like after 2 days of training, we were hitting 130,000 times, 150,000 times magnification. So we are now shooting pictures of like diamond cutting edges, and the whole field of view is 200 nanometers, which is less than the wavelength of visible light. That's just like absolutely insane that you can do something like this. It's been really, really cool and an awesome device, and we are also improving in our projects in leaps and bounds. That's really good.
Pretty cool. I approved the invoice they sent, and Zeiss is really, besides making really high quality equipment, and they are, adorable in terms of what they in the meanwhile are able to do and products they have. But when it comes to service, training, and cost per hour, it's just like, wow.
Yeah. I mean, I'm kind of like a one-man department at Kern, and I think this year I'm spending more than the whole development department.
Yeah, I think so too.
Like those builds are insane. Every time they fly in, I'm just like, woo, Simon is gonna be amused.
Yeah. I was just like, wow, 2 days, and then you have a mount standing on the right side. This is just like, how many people were there? 20? No, it was just one. Okay. Yeah, very good to hear. And I guess people are gonna see a lot more of the Gemini pictures and things you do.
It's been really good. We have a new machine function you're introducing to sales currently. It's a really cool function. We've rolled it out to a couple of customers already. It's the shaping. Simon, you're also a technical expert. Please tell our dear listeners in just a few sentences what shaping is.
I think at that point it's much better if you would actually do that, because the only thing you want to see is me failing at that. But we had our product management meeting right now, and we see there's a lot of new functionality also we're bringing in the next couple of weeks. So if you want to focus a little bit on the shaping part, I think it's great. But we're also looking more into the functionality around the bloom. The LC50, so for example,
that's really the tool measurement laser,
yes, and measuring on the machine. They brought that out, I think, 3 years ago when it hit the market, but for us it wasn't really usable at that time. They made great progress on that, and we see this is something that we're going to offer to our customers in the future on a broader base. That adds a lot of functionality, especially if you're not leveraging the machine 24 hours a day. And especially when it comes to automation, this is always a topic. So I think workpiece handling is a thing that has been focused on many times already in the past. But integration of CMM in such an automated process is still a bloody nightmare. If you see those two things standing next to each other, it's always a kind of a hustle. So this is what we're looking into, leveraging TNC7. So also the fairs coming up in the next couple of months, especially the EMO, we will show a lot more around TNC7 and the new functionality that's going to be in there. And that's great.
Yeah, I mean, the shaping is really interesting to lots of industries. People mostly know it from the watch industry, where it's more called gouache. So the decoration of a watch dial, it actually has quite a couple of applications. We started doing this, I think, in 2020. This was the first time I held a scientific presentation about it. And basically the idea behind shaping is, especially in America, shaping is still kind of a big thing. Lots of shapers still around. It comes from a time when computer control wasn't there, and also when tool technology wasn't there to withstand high cutting speeds. So what they took was basically a lathe tool and moved it in a linear motion across the machine. Then your feed rate kind of becomes your cutting speed, but you can make exceptionally flat parts with this. And there are still a couple of machines actually in productive use in America for this. It has been mostly overcome by surface grinding, because now we have the abrasives that can withstand high cutting speeds. And we kind of rediscovered shaping for us in 2019, 2020, when we were discussing that, especially on like very small structures, it would be nicer if instead of rotating the diamond and being limited by feet per tooth, because actually if you cut more than 10 microns with a diamond tool, you experience massive wear because the diamond is so brittle and it doesn't withstand the forces. So you're limited by feet per tooth to really slow movements. And Kern has always been known for high quality, but also for productivity. And back then we did research, and it was a very it wasn't really a solution back then. It was more like, okay, the machine is capable to doing it, and we have a workaround how we can orient the spindle. And then we started shaping with diamonds on the Kern. We discovered that it actually improves surface quality because you don't have that tooth entry and tooth exit profile you typically get when milling, where you can see your feet per tooth. But also it improved productivity massively. And something our applications department and one of our engineers has been working on is integrating the new TNC7 function shaping into the Kern. And back when I did it in 2019, the results were fantastic, and the results haven't improved since then, but the user experience has improved. Because now what you can actually do is program a 2D contour, and the machine just keeps the tool perfectly perpendicular, so the cutting edge perpendicular to your feed direction. This is basically just a little bit of vector mathematics, which Heidenhain integrated. But now, for example, you can not only do simultaneous movements with the spindle, where you follow a contour, which is nice for watch dials. You can, for example, also take a diamond insert and do a chamfer on a part, just following around the contour of the part, and then you have much quicker than you would have with a chamfer end mill, you have a chamfer which is shiny and flawless. So this is actually a productivity hit as well. It's a really cool functionality which is available for TNC7 machines now. Yeah.
So that was so much better than if I would have done it. So
I think you
great,
need to...
great, you did it.
Yeah, it's fine. You need to start
don't say I
paying
don't know
attention.
it.
No, you know it, but you
no,
need to pay
no.
more attention at the product meetings, I think.
So no, you saw me playing on my mobile. No, so absolutely, and the decision that we made at that time. So this is a typical current thing. So when we came up with the shaping function, everybody wanted to have it, and we got requests all over the world. So there are 2 or 3, perhaps listeners right now, they know they got it. Pressure was high enough, so we got it to them, but we never released it as a standard product because it was not in the, I should say, we didn't hit the quality in terms of user interface, user experience, and so on. And now we're happy that we made the decision to wait until TNC7 because it's really superior. It's super usable. As you said, a totally different approach, different tools. So very efficient, very productive at some parts. And so therefore a great thing to look at. Are we going to show that on EMO?
Yeah, we're gonna show that. This is also really cool, and this shows the level of engineering at Kern and some decisions we make that are just cool for the customer. So on EMO, on the HD Plus, we're gonna run a sample part, and that sample part is gonna show shaping, but it's also gonna show interpolation turning. Interpolation turning is basically where you have a turning tool inside your spindle, and that one is doing a turning operation around the part. But unlike a boring head, the machine is actually doing complex movements with the axis system. So you can, for example, also do larger contours than the diameter of your lathe tool. Because typically with a boring head, you're kind of like limited if you set it 20 millimeters off axis, you can do a 40 millimeter circle. Now, because it's controlling the position of the insert and interpolating a larger circle, you can basically do any shape. We're going to show a sample part doing this. Now, interpolation turning, yes?
Is the spindle turning? No.
The spindle is simultaneously turning with the axis movement. So it's turning at like 1 or 2 RPM. Yeah.
Because
exactly.
that's
So
what I learned.
Like
it was new to me. Actually, you need a spindle that can be clamped. So
not for the
fixed.
interpolation turning.
Yeah.
So in the interpolation turning, it's actually accentuated. You basically have a 6-axis movement at that point.
And what I also learned is there is a way around. So you can use a standard spindle and you just, I don't know, put some electricity on the motor and actually create some torque without the thing is moving, and then it keeps the spindle in position.
That is what we're doing during the shaping. It's actually actuated in positional control and not in speed control. So typically if you hit M3 and the spindle turns on, it's in speed control. So the function drive driving the spindle tries to, for example, keep it at 30,000 RPM. If you get more load, it puts more current in. But there is a second working mode. This is how most rotary axes work, which is positional mode. So during interpolation turning and during shaping, the spindle is controlled in positional mode. And this is something new that Heidenhain has introduced in TNC7, which you kind of couldn't do before with the spindle axis.
Yeah, and I think it's super cool. So for me, as being not a physician or in mechanical engineering or something like that, I think that's really cool.
And the thing I like so much about the interpolation turning functionality is, and don't get me wrong here, nearly no one needs that. It looks impressive as heck, but you only need it if, for example, you have a sealing surface where the requirement on the technical drawing is that the machining marks need to be in direction of the seal. Only then you need it. So it's like a super small functionality. Why did we finish developing it? Because if you pay for shaping, Heidenhain gives you interpolation turning. So this is a function you need to buy with Heidenhain over us, and it's a package. And the engineer developing this, he told me, Marvin, the customer paid for it and it's kind of included, and I felt bad if he doesn't have access to it. It's just like, business-wise, probably a horrible decision, but just shows the love for the technology and for giving the customer good value there.
Yeah, sounds good.
Okay, we are nearly at the end of our episode. We need to focus on the future now. And don't worry, we're not going to become futurists like we did before Christmas, but just like maybe an outlook for the summer. Simon, what's coming up?
Oh my, a ton of stuff. So everybody is busy here. Coming back to it, it feels like how are they called? Santa's helpers are gnomes or
I think elves.
Elves, yeah. Oh, sorry. Wrong movie. It feels like that here a little bit. So there has been 2 weeks of vacation just in Germany, and now everybody's back and they are working like crazy. So deadlines coming close. So yeah, for our dear listeners up front, so what we're going to show on EMO, and the decision has been made a long time ago, is a brand new product. I would say it's the biggest, and I don't know how much we shared in the past, but it's the biggest development project we've ever done. And I would say, even in comparison to Micro HD, it's huge in terms of the effort that went into it. And the name's going to be Fortis HD. So it's going to be Kern Fortis HD. So everyone who's following us and our product portfolio knows it's not going to be on the Micro platform. So it's going to be a totally different platform. I hope for everyone super interesting. It's amazing kind of technology is in there. So if you look at it, it's just like if the housing's off, it's like a living thing. It's like an animal.
Yeah, I mean, I remember when we started the project, I think 7 years ago.
Yeah, nearly 8 years ago.
Or 8 years ago, I saw like a handwritten list of like unsolved engineering challenges. It was like 20 challenges, and they've managed to solve this. And there was stuff with it where you had to like invent completely new technology. It wasn't like, okay, let's adapt something that already exists. It was just like, okay, this is the problem. There is no solution. We now have to engineer a solution to this. And they actually managed to do it. I've been on that machine this whole week. It has been exceptional. I think I spent the whole Monday manically laughing about how good it is. It was fantastic.
Yeah, and it reminds me very much of Micro HD also. So I think we did a little bit better in project management than with Micro HD, and nothing to complain about Micro HD at that point. But I can still remember the machine running, and we're coming close to the first one leaving the factory, and this was just like I was hammering Matthias Fritz all the time. You sure this is going to work? And he says, I'm sure. The X system, you're 100% sure that after 6 months, not 4, 5, 6 failures in the market or something like that, I have to say till today, there's not a single one. So this thing always worked. So the most critical part of it. And so this is what we're going to show. It's going to be an emo. So Marvin convinced me right before that we're going to record a podcast right before emo to tell you a lot more. So if you're going to emo and you have a look at that machine, or even if not, you're going to know everything up front. So it's then just a visual impression that is missing, and that's going to be a point. Yeah, and the next thing is, since we don't have a fair in the United States this year, so Tony and his team's preparing a new, what we call it, an open house. It's going to be a Precision Days at KPI in Glendale Heights in Chicago. We've done that with the opening end of 23. I was injured there too, so this time I hopefully going to be back to normal. And we're going to invite our friends and dear customers, and of course also prospects and whatever. This time we're also gonna show, for the ones who are not going to emo, we're gonna show a lot of new things, and the new thing up front, so everybody has to sign an NDA that comes in for the next 2 days.
And you have to record the smartphones beforehand, just like collect all of them and put them in a box.
You have so much experience at that in the meanwhile visiting customers, so we have to have stickers that you never will get off your iPhone lenses anymore, and stuff like this. Collect passports. So we're gonna do that, and everyone who listens to you who is considering to go to Chicago for that, it's gonna be at the beginning of September. Just contact us, contact Tony Mangold and his team, and we will invite you if there are places left. Can ensure and do everything to host you there for 2 really interesting days. And I will bring my whole family as well as Sebastian. So
including kids?
Including kids,
nice.
Wife, kids, and everything. So they want to see what we're doing there, and they always want to go to Chicago. So we said that's the time. So we're going to have 3 days of vacation. Then we leave family alone, and then for the event they're going to be there. So we are very much looking forward to it. Last time our dads were with us, so Sebastian's dad and my dad. They were preparing white sausage on the Friday, classical, traditional Bavarian white sausage. And we will see what we do this time. Yeah. So I think that's the most important things. There's a lot of communication coming up. We're doing tons of stuff. You're doing tons of stuff for the emo. That's not just going to be for emo, but parts, super nice, interesting parts that we're going to see for the next 2 years for sure. So that's going to be new. A lot of new stuff around also Micro HD, HD Plus, the latest results. And
I think it's also going to be our biggest emo booth ever, right?
Yeah. And they're also killing us. It's all...
I mean, like, if you talk to me about my expensive microscope, look at the booth rental fees.
Okay. So I think they in sales for the emo, they hire the guys that made pricing for Zeiss before. This is a big effort. Yeah.
So beginning of September, it's the open house days in Chicago. Get in contact with Tony if you want to attend. And then at the end, I think 20th of September, we have emo in Hanover, Germany. It's going to be the largest trade show of the year for machine tools. Very interesting, and we're going to show lots of new things.
Yeah, perfect. I'm going to be there. Sebastian's going to be there. A lot from the team. Marvin's going to be there. We have a ton of people. Not so many salespeople this time. No. So we have a lot of engineers and so on. So come around. Don't be afraid. It's going to be fun.
Yeah. Awesome.
If you need tickets, you get free tickets from Kern, of course,
Yes,
for the emo.
just contact your salesperson and then you get free tickets.
Yeah.
Exactly. Awesome. Simon, thank you so much for your time.
Thank you very much,
Really
Marvin.
fun episode. I'm looking forward to recording the next one next week. Now it's
Yeah.
on record. And
Okay.
talk to you next time.
Okay. Thank you very much. Marvin, have a good one.